accurate down to whatever nanoseconds or microseconds. But that usually is done by a hardware device, also not done by software. The capturing of the time of when you receive the echo is actually done by a timer on the device itself, and then software has actually a lot of time to read the timer and see how much time has elapsed since the pulse is sent and before it is detected. Yep.
How do you pause thread?
How do you pause a thread in Linux? There's a system call to do it, but I cannot know because I have never personally used pthreads in my life. I wrote my own real-time kernel, but I have never used real threads in the context of Linux. But there has to be a call to support that. So if you say man threads.
Does pthreads work in Windows? I've always used create threads.
Is Windows POSIX compliant? I don't think it is even close. NT4 was POSIX compliant?
Well, it had a POSIX module, but I don't believe it had anywhere near the POSIX compatibility.
Well, POSIX has different versions as well, so maybe it is compliant to an earlier version of POSIX, but not with a later version. Some of this stuff is still being changed. Okay, so if you read conduit, which is not something that we'll talk about in this class, you can actually see that it is still the standard is still morphing. So they have suggestions of how that should be handled. It's a condition weight. It's basically a signal weight, but that has nothing to do with the signals that we have talked about so far. It's not a system signal. It is a software signal for synchronization amongst threads. So it's an entirely different type of construct compared to the threads. Compared to the signals that we talk about. Detach equal exit kill 1 test cancel. Okay. I don't see anything here that is similar to what you're looking for, but I think pthread cancel. Okay, let's look at create, because create probably is closest to what we are looking for. Is it create or create? What did I miss? pthread underscore create. pthread underscore create. No, maybe I did not install the document. Well, in that case, Google it. pthread underscore create.
Mutexes. Mutexes.
You should not need the mutex to pause a thread.
I saw that pthread mutex pause.
Yeah, but I don't think you need that to pause a thread. You're basically saying, how do I voluntarily give up control? But then the question is...
from within a thread?
Yeah.
Well, because, say you have an event dispatcher or something, one thread and then another thread's running, you want to pause that and change the IP to something else?
You can wait for a signal. You can always, just do a signal wait or cond wait. That's one thing you can use with the cond concept. Okay, let's take a look at exit. I know exit is not the right function, but maybe it has over here. Okay, let's look at the header file. This gives us a list of all the things we can do with a thread. Detach equal create. Yeah, the mutex is for mutual exclusion. It is really not for a single thread to say, okay, I'm done so far. I want to give up control so somebody else can get the execution time. So maybe it's not supported. That cancel type. Yeah, there's nothing here. You can always use sleep or
How do you make
the sleep will make the process sleep, right?
Yeah.
Not a single thread. Okay, let's look at detach, because once a thread is detached, it cannot be joined anymore. Nope.
But if you detach it, how would you reattach it where it left off?
Detaching means that a thread can no longer be joined with the main thread. So you lose the ability, okay, so you basically say, okay, this is the main thread, I want to do something in parallel. In most cases, you want to make it so that it's joinable, so that down the line, the main thread can wait for the other thread to complete, then the two threads will join into one single path again. When you detach a thread, it makes it so that it's no longer joinable. So the other thread has to die by itself or be explicitly killed by the main thread, but there's no way for the main thread to say, okay, I'm going to wait for the other thread to complete before I continue to perform, the next few steps.
If you detach a thread, does it become process, or is it still part of the...
It is still a thread. It is still a thread. It is just no longer, you cannot use p-thread join to basically wait for the other thread to be completed and then continue execution anymore. So that, as far as I can tell, there's no way to do it with the p-thread model in Linux. Yep.
Can you use p-thread kill to send it sig stop and sig resume?
Yes, you can, but when you use kill, you are applying that to the entire process. So you have to be very careful, which thread in the process is paying attention to that signal.
Well, no, there's a kill function to send a signal to a specific thread in a process.
That may be the case. Okay, so instead of talking about p-thread, which is important, but I also want to kind of switch gear a little bit here, because we talked about, the micro mouse application, how people are not using a multi-threaded model because it's too much trouble to learn how to use, threading. But that's actually not true, because, I wrote a real-time kernel for that architecture that most micro mouse or micro mice use. So in this case, we have, about the same thing here. And, this is really old stuff here. I wrote this way before I started to teach this class, which is this semester. You can see that the last time I revised it was 2008. A process is a program in execution. This term is more useful in desktop or computers that can run multiple applications concurrently, which is not the case here with a $10 chip that has, everything on the chip itself. Okay? Those are called microcontroller units, which is basically a computer on a chip. They're not really powerful. They don't have 32-bit, ALUs, but they're sufficient for many other applications. A thread, I explained the thread here. A thread is a process has at least one thread. A thread is the context that is necessary to execute code sequentially as specified by a program source code. A process can have multiple threads, but all these threads must share all variables and data structures that are either statically allocated or allocated via dynamic memory allocation. So basically, it's not conflicting with the p-thread explanation. On the other hand, threads do not share any variables and objects that are stack-based. So this is also important, because anything that are stack-based are individual to the thread itself, because each thread has its own stack that is separated from the other threads. Okay? Are we okay so far? We're basically looking at threads from two perspectives. Before this, we were looking at it from the p-thread perspective, which is a Linux big system type of perspective. This is looking at it from a very micro architecture perspective, because the entire thing only has 128 kilobytes of program space and 4 kilobytes of data space. Okay, which is not a whole lot. 4 kilobytes as in 4,096 bytes. Okay, when was the last time you wrote a program that only needs 4 kilobytes or less of data space? Yesterday. In most implementations, every thread has its own stack. Exceptions include the real-time kernel published by Zeroed Inc. at least up to 1998, because that's when I left that company. Okay, so multi-threading. There's not much for a kernel to do if a program only executes as a single thread. A minimum amount of a real-time kernel is somehow to support multi-threading. And we all know a processor, especially the cheaper processors that we use on a micro mouse robot, only has one single ALU. Okay, now this is not true for Intel processors, because Intel processors definitely have multiple ALUs, and the hyper-threading hardware actually supports multiple threading on the hardware. Okay, each is that true? Hyper-threading is, the mechanism